So the first thing overall that I've noticed as y'all working through this is some people aren't actually writing down their notation of stuff. And again, you don't have to notate it exactly like I am, but it's got to be something. So this says, find the probability that it points to an even number given that it points to a shaded region. So probability that it is even given that it points to the shaded region. Now, if you didn't use those exact letters, that's fine. You can use whatever you used. I also noticed some people are using A and B for absolutely everything. There's nothing wrong with that. Personally, that would confuse me because I wouldn't be able to remember what was A and what was B, and I'd have to keep rereading the question. So I would suggest that you make it something that goes with the problem. Again, you don't have to if it makes sense to you, but if you're getting yourself confused, that might be one of the problems. Once you've got that written from the question, then we should all be able to get the probability of it shaded and even over the probability that it's shaded, right? Everybody okay so far with that? Now I'm going to write, the next thing I write down, I don't want you to copy down and I don't want you to like scribble out and erase anything you have. I just want you to follow me because I'm going to tell you right now it's not correct, but it's probably how a lot of you have done it. And I understand why you're going down that road. I tried to do multiple different examples and I did one like this. I just didn't kind of point this one thing out, and I think that's leading to some misconceptions here. So one school of thought here when people are working this is to say, all right, well then that means I need the probability that it's shaded and even. Well, over here there are 4 shaded sections out of a total of 8. And there are 1, 2, 3 that are even out of 8. So shaded and even over the probability that it's shaded, which again would be 4 out of 8. Okay, now I've already told you that that's not correct, but just go ahead and be honest. How many of you set it up that way? And it's okay. All right, and I've had many more in most of my other classes. And if you did not set it up that way, do you understand why somebody might set it up that way? Because it's the whole and thing. And even if you didn't on this one, you might have on another one and you didn't realize it yet or whatever. So that's why I want to make sure that we understand this. Like, when do you use 2 fractions? When do you use 1? Here's the problem, is that this right here is one event, right? I'm not drawing a 7 and then drawing an 8. One thing is I'm spinning it once and it's got 2 attributes. When there's just one event, this process works sometimes, but not all the time. And I can't tell you with super confidence right now if that's just a coincidence or not. I can come up with a lot of times where that process will work, but I can also come up with a lot when it won't. And I feel like there's so many times that it will. It's not just a coincidence. There's something else going on there that, you know, we probably need to look deeper into or whatever. But instead of worrying about when I can do it that way and when I can't, I'm going to give you what works every single time and how to think it through it that way. And then I've got to figure out a way to make sure I understand why it works sometimes and why it doesn't, because I haven't found the key to that yet. It's probably something real obvious in front of my face, but I've talked to a couple other teachers that can't really give me a good answer on that either, so I'm struggling with who I'm actually going to ask at this point, but I'm going to get it figured out. If there's just one event, and here there is one event, the safe thing to do that will work every time, since this works sometimes and not all the time, the safe way to look at this is that if there's only one event, then in the numerator there should only be one fraction. And you will have enough information to come up with that one fraction without the multiplying. What I want up there is the probability that it's shaded and even. How many are shaded and even? 2 out of a total of 8, okay? And then in the denominator, the probability that it's shaded, how many are shaded? 4 out of 8, okay? Does that make sense to you? Everybody with me on that? Okay, and then you just solve it from there, okay, which we'll just go ahead and finish it. It's going to give me 2 over 8 times 8 over 4. Those cancel out. That's 2/4, which is 1/2. Okay, everybody okay with that one? So somebody said, so all of them are going to be like that. Well, no, because there could be, again, if I say I'm going to draw a 7 and I'm going to keep it, and then I'm going to draw an 8, what's the probability I get an 8 if I've already drawn a 7? So that's 2 events. Then in the top, I would need the 2 fractions and go with it that way. So the safest thing to do, remember, be consistent and simplify it as much as you can. If there's one event, 1 fraction in the numerator. Now I want to show you a time where you would get the same answer so that you understand why. We did this yesterday. Okay, this is one event. This is from your notes from yesterday. One event, and you don't necessarily have to get them out, but one event, and we have 1 fraction in the numerator. And I did it that way. I didn't really tell you why. I don't really think I was thinking about you being confused that way. I understand why you are, but if I did it the other way, where there's two fractions, I get the same thing. Because this is the probability that it is even and less than 5 over the probability that it's even. You're just rolling it once. But if I find the probability that it's even, right, that would be 5 out of 10. Probability that it is less than 5, that's 4 out of 10, right? So that's going to give me 1/2 times 2/5, which is 2/10, which is the same thing I have in the numerator right here. So if we had worked that one that way, we would have gotten the same answer in the end. And this is one of those things that can make probability so confusing. You think you get it, it's working, and then it doesn't work. So even though it does work here, it didn't work on the other one, which means it's not going to work every time. Okay? It will work for some on that green paper. It will not work for all of them when you're talking just one event. So one event, do not go down this road. One event, one fraction in the numerator. You with me? And if you can do it that way, you'll realize it all makes a little bit more sense, and you'll be fine with it. Okay? Any questions about any of that? All right, and if it's a reasonable sample set, write it out. When it's talking about the numbers 10 through 40, I mean, I can show you on my key. I literally wrote all of the numbers out because it started asking me questions and I was getting the numbers mixed up in my head. I was like, I've got to see it all. So it's kind of a big sample set, but me seeing those numbers there and being able to count what I needed was helpful for me to get the right answers. So there's no shame in that. Of course, if it's millions, don't do that. But that was a pretty large one, but still one I felt like I needed to write out. Okay. Anybody have any questions on any of this yet? All right.